non-commercial occupancies, the National Electrical Code, or NEC, mandates specific requirements for emergency power, often referred to as EMG power, wiring. This includes areas such as offices, gift shops, hallways, cafes, and kitchens. The core principle is that all wiring for emergency lighting systems, encompassing both power supply and control circuits, must be installed within a raceway system unless the NEC explicitly permits an alternative. A raceway system provides a protective enclosure for electrical wiring, shielding it from physical damage, environmental factors, and potential fire hazards. The most common type of raceway is conduit, which can be either metallic, such as rigid metal conduit, intermediate metal conduit, or electrical metallic tubing, or non-metallic, such as rigid polyvinyl chloride conduit. Other approved raceway systems may include wireways, cable trays, and surface metal raceways, provided they meet the specific requirements outlined in the NEC for the intended application. The requirement for raceway systems for emergency power wiring stems from the critical nature of these systems. Emergency lighting and power are designed to provide essential illumination and power during a power outage or other emergency situation, ensuring the safety and evacuation of occupants. Because these systems must function reliably under adverse conditions, the wiring must be protected from damage that could compromise the operation. The NEC provides detailed specifications for the installation of raceway systems, including requirements for support, grounding, and conductor fill. Firstly, raceways must be securely supported to prevent sagging or displacement. The spacing of supports depends on the type and size of the raceway, as specified in the NEC. Secondly, metallic raceways must be properly grounded to provide a low impedance path for fault currents, reducing the risk of electrical shock and fire. Grounding requirements vary depending on the type of raceway and the grounding system employed. Thirdly, the number of conductors permitted in a raceway is limited by the NEC to prevent overheating and insulation damage. The allowable conductor fill depends on the size of the raceway, the size and type of conductors, and the ambient temperature. In addition to the general requirements for raceway systems, the NEC includes specific requirements for emergency lighting and power circuits. These requirements address issues such as circuit separation, overcurrent protection, and transfer switches. Firstly, emergency circuits must be physically separated from normal power circuits to prevent a fault in one system from affecting the other. This separation can be achieved by using separate raceways or by installing a barrier within a shared raceway. Secondly, emergency circuits must be protected by overcurrent devices, such as circuit breakers or fuses, to prevent damage from overloads or short circuits. The size of the overcurrent devices must be appropriate for the ampacity of the conductors and the rating of the connected equipment. Thirdly, emergency power systems must include a transfer switch that automatically switches the load from the normal power source to an alternate power source, such as a generator or battery, in the event of a power outage. The transfer switch must be rated for the voltage and current of the connected load and must be designed to operate reliably under emergency conditions. While the NEC generally requires raceway systems for emergency power wiring, there are some exceptions. For example, the NEC permits the use of cable assemblies that are specifically listed for use without raceways in certain applications. These cable assemblies must be installed in accordance with the manufacturer's instructions and must be protected from physical damage. Another exception applies to low-voltage emergency lighting systems that operate at 30 volts or less. These systems may be installed without raceways, provided the wiring is protected from physical damage and is installed in accordance with the NEC. However, it is important to note that these exceptions are limited and may not apply to all emergency power installations. It is always best to consult the NEC and local electrical codes to determine the specific requirements for a given project. The NEC is a comprehensive document that is updated regularly to reflect changes in technology and industry best practices. It is essential for electrical contractors, engineers, and inspectors to stay up to date on the latest NEC requirements to ensure the safety and compliance of electrical installations. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. Chapter 1 covers general requirements such as definitions, wiring methods, and grounding. Chapters 2 through 7 cover specific types of electrical systems such as branch circuits, feeders, services, and special occupancies. Chapter 8 covers communication systems such as telephone, data, and cable television. Chapter 9 contains tables and examples that are used to apply the requirements of the NEC. Within each chapter, articles address specific topics in more detail. For example, Article 517 covers healthcare facilities, and Article 700 covers emergency systems. Within each article, sections provide specific requirements for the topic at hand. For example, Section 700.12 covers the wiring of emergency lighting circuits, and Section 700.26 covers the testing and maintenance of emergency systems. To properly apply the NEC, it is essential to understand the definitions of key terms. The NEC defines terms such as approved, qualified person, and raceway in Article 100. These definitions are used throughout the NEC to ensure consistent interpretation and application of the requirements. In addition to the NEC, local electrical codes may also apply to emergency power installations. Local codes may be more stringent than the NEC in some areas, reflecting local conditions and concerns. It is important to check with the local electrical inspection authority to determine the applicable codes and regulations for a given project. The installation of emergency power systems is a critical task that requires specialized knowledge and skills. Electrical contractors who perform this work must be properly licensed and insured, and they must have a thorough understanding of the NEC and local electrical codes. It is also important to use quality materials and equipment that are listed and labeled for the intended application. The use of substandard materials or improper installation techniques can compromise the safety and reliability of the emergency power system. After the emergency power system is installed, it must be tested and inspected to ensure that it meets the requirements of the NEC and local electrical codes. The testing should include a functional test of the transfer switch, a load test of the emergency generator, and a verification of the proper operation of the emergency lighting system. The inspection should verify that the wiring is properly installed, the raceways are securely supported, and the grounding system is adequate. Regular maintenance is essential to ensure the continued reliability of our emergency power systems. The maintenance should include periodic inspection and testing of the system components, as well as replacement of worn or damaged parts. The frequency of maintenance depends on the type of system and the operating environment, but it should generally be performed at least annually. In summary, the NEC requires that all wiring for emergency lighting systems in commercial occupancies be installed in a raceway system, unless specifically permitted otherwise by the NEC. This requirement applies to all areas of the building, including offices, gift shops, hallways, cafes, and kitchens. The purpose of this requirement is to protect the wiring from physical damage, environmental factors, and potential fire hazards, ensuring the reliable operation of the emergency lighting system during a power outage or other emergency situation. When installing emergency power wiring, it is essential to follow the requirements of the NEC and local electrical codes, use quality materials and equipment, and perform thorough testing and inspection. Regular maintenance is also essential to ensure the continued reliability of the system. By following these guidelines, you can help to ensure the safety and well-being of building occupants during an emergency. The NEC emphasis on raceway systems for emergency power is not arbitrary. It's based on years of experience and analysis of electrical failures. Raceway systems provide a robust physical barrier against a range of threats. Firstly, physical damage from impacts, abrasions, or accidental contact with equipment. Secondly, environmental factors such as moisture, corrosion, and extreme temperatures. Thirdly, fire hazards by containing a fire within the conduit or raceway, preventing it from spreading rapidly. Fourthly, electromagnetic interference, EMI, which can disrupt the operation of sensitive electronic equipment connected to the emergency power system. In addition to these protective benefits, raceway systems also facilitate future maintenance and modifications. They allow for easy access to the wiring for inspection, repair, or replacement. They also provide a clear pathway for adding new circuits or upgrading existing ones. The NEC recognizes that some situations may warrant exceptions to the general requirement for raceway systems. However, these exceptions are carefully controlled and are only permitted when certain conditions are met. For example, the NEC allows the use of Type MC cable, metal-clad cable, without a raceway in some cases, but only if the cable is installed in a manner that protects it from physical damage and is supported at specific intervals. Similarly, the NEC allows the use of flexible metal conduit, FMC, for short runs, but only if it is properly secured and grounded. These exceptions are not intended to be loopholes that can be used to circumvent the general requirement for raceway systems. They are intended to provide flexibility in situations where the use of a raceway is impractical or unnecessary. When considering an exception to the raceway requirement, it is important to carefully evaluate the potential risks and benefits. It is also important to consult with the local electrical inspection authority to ensure that the proposed installation meets the applicable codes and regulations. The NEC is not a static document. It is constantly evolving to reflect changes in technology and industry best practices. The NEC is updated every 3 years, and each edition includes revisions and additions that address new issues and concerns. It is important for electrical contractors, engineers, and inspectors to stay up to date on the latest NEC requirements to ensure the safety and compliance of electrical installations. There are several resources available to help you stay informed about the NEC. Firstly, the National Fire Protection Association, or NFPA, offers a variety of training courses and publications on the NEC. Secondly, the International Association of Electrical Inspectors, or IAE, provides resources and support for electrical inspectors. Thirdly, many electrical contractors and engineering firms offer in-house training programs on the NEC. In addition to these formal resources, there are also many online forums and websites where you can discuss the NEC with other professionals. These online resources can be a valuable source of information and support. The NEC is a complex document, but it is essential for ensuring the safety and reliability of electrical installations. By understanding the NEC requirements and following best practices, you can help to protect people and property from electrical hazards. When working with emergency power systems, it is important to remember that these systems are designed to operate under stressful conditions. They must be able to function reliably during a power outage, a fire, or other emergency situation. Therefore, it is essential to use high-quality materials and equipment, follow proper installation techniques, and perform regular maintenance. The cost of a properly installed and maintained emergency power system is small compared to the potential costs of a failure. A failure of the emergency power system can result in loss of life, injury, property damage, and business interruption. Therefore, it is important to invest in a reliable system and to take the necessary steps to ensure its continued operation. The requirements for emergency power systems extend beyond the wiring and raceway systems. They also include requirements for the power source, the transfer switch, and the emergency lighting fixtures. The power source for an emergency power system can be a generator, a battery, or a combination of both. The power source must be sized to provide sufficient power to operate the emergency lighting and other essential loads. The transfer switch is a device that automatically switches the load from the normal power source to the emergency power source in the event of a power outage. The transfer switch must be rated for the voltage and current of the connected load and must be designed to operate reliably under emergency conditions. The emergency lighting fixtures must be designed to provide adequate illumination for safe egress from the building. The lighting fixtures must be powered by the emergency power source and must be designed to operate automatically when the normal power supply fails. The NEC includes specific requirements for the location, spacing, and illumination levels of emergency lighting fixtures. In addition to the NEC requirements, there may also be local codes and regulations that apply to emergency power systems. These local codes may be more stringent than the NEC in some areas, reflecting local conditions and concerns. It is important to check with the local electrical inspection authority to determine the applicable codes and regulations for a given project. The installation of emergency power systems is a specialized task that requires specialized knowledge and skills. The electrical contractors who perform this work must be properly licensed and insured, and they must have a thorough understanding of the NEC and local electrical codes. It is also important to use quality materials and equipment that are listed and labeled for the intended application. The use of substandard materials or improper installation techniques can compromise the safety and reliability of the emergency power system. After the emergency power system is installed, it must be tested and inspected to ensure that it meets the requirements of the NEC and local electrical codes. The testing should include a functional test of the transfer switch, a load test of the emergency generator, and a verification of the proper operation of the emergency lighting system. The inspection should verify that the wiring is properly installed, the raceways are securely supported, and the grounding system is adequate. Regular maintenance is essential to ensure the continued reliability of emergency power systems. The maintenance should include periodic inspection and testing of the system components, as well as replacement of worn or damaged parts. The frequency of maintenance depends on the type of system and the operating environment, but it should generally be performed at least annually.